Hello everyone, in this video, I will show you how to apply soil pressure to our structure in STA, and we will talk about basement rigidity. In this way, I prepared an example model. Our first floor is completely surrounded by basement walls. Only one side of our second floor is surrounded. Let's start first. We open our axis from here and come to our first floor. Here, we click on the ground section, select the ground, location, and click our button. This way, the program automatically detected it. Now let's open the view, the soil view from our settings. We select the soil view. As you can see, the first floor was automatically detected. But we also need to apply our soil pressure to these areas on the second floor. How are we going to do this? Let's get started. First, let's talk about what the point types mean. We have 3 point types. The first type, the second type, and the third type. The first type of point represents the beginning, and our number 1 point is a first type point and indicates the start. The second point type represents intermediate points. The third type of point represents the end. Now we will add an intermediate point to this area. On the second floor, for this, we need to add an axis. Yes, 30 centimeter axis will be sufficient for us. We will move the green line we just saw onto this axis. So why are we doing this? Because we want to raise the soil pressure 1 floor up in this area. As you can clearly see, we will be moving the axis between the numbers 3 and 4. Backwards, as you can see. Yes, we are raising points 3 and 4 by approximately 6 meters. As you can clearly see, there was a very sloped transition. If we wanted a direct and sharp transition, we would add more points in between and make necessary adjustments from there. We can add points in this way and shift these points right here to reduce the sharpness. Now that we have adjusted our height, there are some points we need to arrange here. For example, the unit volume weight of the soil has been taken as 1.8. You can adjust this according to your own project and also adjust the opening. If you have surcharge load, meaning if a highway passes over the top part of your ground, you can consider the vehicle loads here as 10 tons. The program will automatically take this into account. Additionally, you can use different coefficients for soil loads. Finally, this button is necessary to transfer the ground thrust to the floor diaphragm. You need to check this. This tab is used in structures with expansion joints. I will explain this in the next example. Now we have made our adjustments. You can see the loads transferred to the panels by saying that the soil load has been transferred. Now let's save our structure. and analyze it. Yes, our analysis is complete. Let's go to the second floor and examine our soil loads. As you can see, there is a slope transition here on the second floor. The reason for this is as follows. Our driving load has been activated here. Therefore, there is an inclined transition. If we didn't have a surcharge load, it would be considered as zero. You can see it this way. Let's set this to 0, transfer it, close it, save it, and analyze it again. We are moving to the second floor. As you can clearly see, it will definitely continue starting from 0 when we get to the lower floor. We can clearly see our soil load here in the shape of a parallelogram. Additionally, the values of 1.8 and 30 are also clearly visible here. Soil pressure is applied to our structure in this way. Now we will discuss the effect of soil pressure in structures with diaphragms. We are opening our example structure, file named example3, inside our sample data. We are opening our diaphragm option, general options, analysis options. And this button will show us different diaphragms. Then we select the diaphragm from the floor layout. As you can clearly see, you indeed see two different diaphragms. In these cases, after entering the soil pressure, we will see that we transfer it. And instead of clicking on automatic selection, we enter our coordinates for the first floor from the button on the left side, and this is how we affect structures with expansion joints. Now we will talk about basement rigidity. Let's open a sample structure. One floor of this structure is surrounded on all 4 sides, while the second floor is surrounded on 3 sides. According to Turkey's earthquake regulation, it must be surrounded on at least 3 sides. Our structure meets this physical requirement. First, let's apply our soil loads. They have already been applied. Let's apply them automatically and efficiently. We are recording 001. Now, how will we define our basement floor here? When we arrived here, you set the earthquake load's lower height to 0. The earthquake will affect from the foundation, but if you consider the first floor as a basement floor like here, it will be affected in a triangular shape starting from the top of this first floor. Additionally, the Turkish regulation requires that the ratio of the entire period of our structure to the structure above the basement floor be less than 1.1. STA performs this period control automatically. It is sufficient to enter the information here. Now let's save and analyze. And let's examine our period control together. We are looking at our seismic report. It needs to be less than 1.1. But it hasn't met the X direction either. Therefore, the program is giving us a warning that your basement floor rigidity is insufficient. To resolve this issue, if you enter 0 in the building information input, the program will not perform this check. See, it didn't give the warning. That's all I have to say in this video. I wish everyone good luck with their work.